Hello friends, so welcome in the new video, and in this video again we will see GSM interface with STM32 microcontroller, but this time we will send SMS. So sending the SMS through GSM is more easier than receiving message, because on receiving message we have to write multiple logic, buffer, all these things. But sending message is quite simple because you have to simply send some AT commands on UART. So you can see the connections. So our GSM module is connected with our this nucleo board via UART. So it's basically TX and RX. Ground commonly is connected through the breadboard. And to make this more interesting, here I am using proximity sensor, and that proximity sensors is having three pin. One is power supply, one is ground. So you can see these two, both the pins are connected with this power supply and ground of this board, and third pin is output pin. So you can see output wire is connected with this PB4. So this is actually PB4 pin, and we will continuously monitor this. So for continuously monitoring, we have to use polling mechanism. But again, to make this video more interesting, we will going to use interrupt based mechanism. So instead of continuously monitoring the thing, we will simply enable the interrupt, and then we will wait for the interrupt. When interrupt will occur, means when some activity will detected by this proximity sensor, it will send high signal to PV4, and based on that interrupt, either rising edge or falling edge, microcontroller will take action, and as action we will simply send SMS. Again, during SMS sending part, we will also going to turn on one LED, right? Onboard LED is there, so we will going to use PB7 pins LED. So whenever activities will detect, it will turn on the LED, it will send the SMS, it will complete the process, and it will turn off the LED. So this will be end-to-end process, right? So this will be our block diagram. So instead of push button, consider this proximity sensor with connected with PB4, UART, via UART this GSM and STM32 are connected, and onboard LED is there, which is PB7. And to sending the SMS, you have to simply follow this 80 plus CMGF is equal to 1, 80 plus CMGS is equal to your phone number, and then you have to simply type your message like hello for GSM, hello from GSM, or LED on, or whatever, and then you have to press Control Z. It's like a end of the message, right? And this ASCII of this end of the message is this 1A X1A, right? So basically, it will consider as the end of the message. So we will simply pass these three command, but we will pass only and only when interrupt will trigger, right? So let us start this programming. So here is our this controller is selected. So first of all, you have to provide the clock. Okay. Then we have two pins. One is PB7. So connect this PB7 as output. So we have to configure as GPI output. And PB4 is having interrupt. So if you don't know about interrupt, or if you have any confusion, please watch my previous videos in which I explain uh, about interrupt, what is polling versus what is interrupt, how we can use this, what is priority based interrupt, everything. Okay, so on PB4 we have our proximity sensor connected, so I am just configuring it as a GPIO external interrupt pin, right? So it will consider as the external interrupt, right? So now after these two pin, we have only one thing which is still we have to configure, and which is that is UART, because our GSM module is there, and definitely to send SMS we have to use this UART. So simply enable it asynchronous, and you can see this will configure on PB10 and PB11. So in our circuit also we have connected our GSM module with this UART3 only, and let us change this baud rate to 9600 simply. Okay, so that is all. Now, one thing we have to still we have to configure, that is NVIC, because we are using interrupt. So in NVIC you have to enable that. So whatever interrupt we have just configured external interrupt for, so you can see external line for interrupt, so we have to enable this. Now we have interrupt, we have enabled interrupt, but now when interrupt will detect, when interrupt will trigger, that also we have to specify. And for that, go to the GPIO. We have PB4 pin for external interrupt. Select this and change this GPIO mode to external interrupt mode, rising falling edge trigger detection. Means either on rising edge or on falling edge, this interrupt will trigger. Okay. And one more thing, here we have GPIO pull up, pull down. So I'm just making it pull down because initially the voltage level for the PV4 should be low. That's why I'm just configuring it as a pull down. Whenever some activity will detected, that pin will become high. So you can say pull up, and at that particular moment, rising edge will be detected and interrupt will enable. Right. So now we are going to simply generate the code. Now it will generate the code. Now we have the generated code. Here you can see the hardware also in the image. Right, so this is the proximity sensor, this is GSM module, this is our microcontroller. So let us start with the variable initialization. So let us take one variable. I'm just giving any name like button rest is equal to 0. So initially button press variable is having 0 value, right? And I will simply check when this button press will be 1, I will send the SMS. So for sending SMS, we have to write some command through UART. So instead of writing this command multiple times, let us initialize the function for that. So as in a previous video also we have used this. So let us define one function, send command, okay, character star cmd. So instead of writing this command multiple times, we'll simply call this function send command. Okay, sorry, send command. And here we have to write our UART transmit command, HR UART transmit. And in argument, we have to provide UART handler, message size, and timeout period. So UART handler is user3. So you can find this. Okay, then UART. Then our message, which is CMD, then length of the message, star length CMD, and then simply timeout 100. Yeah, we can click this. Now we have to typecast this into int 8, right? That is also required, and that's it. So we have this function. Now let us check this button press. In while 1, I will simply check if button press is non-zero, then send the message. Okay, so to send the message, we have this function. So let us write this. First write at command /r/n, then write another command which is at plus cmgf is equal to 1. Okay, at plus cmgf is equal to 1. This is another command. And then we have to provide our mobile number. 80 plus cmgf, 80 plus cmgs, okay, is equal to, I'm removing all this, and now I'm giving any mobile number 91xxxxxx /n. Okay, and then we have to simply type our message. So let us type send command LED on, and then end of the message. So that is X1A. So that is considered as the end of the line. Okay. And now in between this, we have to add some delay. So let us add the delay. Also, after sending SMS, we have to make this trace is equal to 0, because again it should send this. And one more thing, as I told you earlier, that we will also blink the LED, onboard LED. So for that, let us use this function. So let us initially, when this button press is equal to will become 1, let us turn on the LED, and after this whole process, let's turn off the LED. So this is what the function to send the message. Now, who will going to change the value of this button press? So for that, we will going to write one callback function, right? So if you know what is callback function is, then you must know that this function is already given in the GPI part. If you don't know, please watch my previous video, and here just search for EXTI callback function, right? And here the function. So take this as it is. Here we will going to write very small logic, not much. So void HLGPI external interrupt callback. So whenever interrupt will trigger, it will automatically call this function. So first thing is we have to check. We have to check whether the interrupt is come from our pin 4, because our proximity sensor is connected with pin 4, right? So we have to make sure that the interrupt should come from that pin only. Okay, so you have to check if GPIO pin is equal to GPIO 4, then and then do something, else do nothing, right? Now what is something and what is nothing? So simply make this button press is equal to 1 if this interrupt is come from pin number 4, otherwise make this 0. Okay, so that is what the end of the logic. Now I'm debugging the code to check whether any error is there or not, and still I'm not use my actual mobile number, but I will show you the process, and then later on I will change this to my actual number, and then I will show you how message will receive from the GSM. So here just we are checking for any possible error, and if everything is perfect, we will simply load this file on our microcontroller. Here you can see it is perfectly compiled. Now let us release this, and using this run configuration you can upload the code also, right? So let us start that process also. Meanwhile it will release the part, run configuration. And here you have to simply click on this application, and automatically you can see your new project will added here. The name is test GSM SMS. Your new code should come under this STMC++ application. Then we will select the that, we will select required file, and then we will simply run the code. So it will upload the code on our board. So you can see this is our program. Now here select the target or board or file. So in release we have this file. Simply run this. Now I have to simply disconnect this board and again connect, and then again load this. So it will upload this on our microcontroller. Using this LED you can observe that part. Now I'm resetting this. Now you can see whenever I will just put my hand ahead of this, you can see here activity is detected, here LED is on, and now it will send the SMS again. And now I just not provided my actual mobile number, but let us change this to actual number. and then I will show you. So now I change this to actual mobile number. Let us rerun this. And now you can see this is it is sending the message. Now on screen you can see message received. Again I am doing this. You can see again message is received. So this is what for today's video. So this is the end of this GSM module part. If you have any question, you can write in the comment, and if required, we will make one more video on this. So till then, if you like my work, please like my videos, share my videos with your friends, subscribe my channel. Till then, bye bye. Thank you. Thanks a lot.